Hello, this is the luckiest maths teacher in the world, and you should feel privileged because you're about to embark on an amazing journey where you learn about algebra. Now, contrary to actual belief, algebra is actually so helpful in our day-to-day lives. We wouldn't have computers if not for algebra, so you're lucky that you get to learn about this for the next 5-6 years of your life. So before you learn about it, you have to kind of know what it is. So best definition I ever heard of algebra was that is the study of operations. Operations being plus, minus, times, divide, square rooting, all that fun stuff you know about. Colloquially, if you were to ask, say, one of your older friends who studied it before, what's algebra, they'd say, oh, that's the area of maths with all the letters. Okay, and they'd be right. That's a good way to think about it. In algebra, we use letters to represent numbers because it actually makes a lot of calculations so much easier to visualize and to solve. So, what do I want you to get out of today? I want you to be comfortable using letters to represent unknown numbers. Now, during this video, if at any time you want to copy something down, all you have to do is hit the pause button and copy it down, and as usual, ask your amazing teacher if you have any questions. Okay, so let's get started. So to understand what's going on here, I want you to pretend that I have this really cool +3 machine. So, what does this machine actually do? Well, you put into it any letter or number, and it adds 3 to it. So if I put a 6 into this machine, out will come 6 plus 3, 9. If I put 12 into this machine, out pops 15. So, what happens if I just put in any random number? So, I'm just going to write the word number. So I put a number into this machine, and whatever number that was, out pops that number plus 3. Okay? Seems pretty simple, doesn't it? But you know what, guys? I have to admit, I'm lazy. I want to write out number every single time I'm doing a mathematical problem where there's an unknown number. So I'm actually going to be a little bit lazy and write the letter N instead of number. So when I put 12 in to the machine, out pop 12 plus 3. When I put in a number, out pop the number plus 3. If I put 21 into this machine, out will pop 21 plus 3. So if I put N into this machine, out will pop N plus 3. So N here is just standing for an unknown number. I don't know what that number is. At this point, I don't need to know what that number is. All I'm saying is if I put in N, out will pop N plus 3. But what if I don't want to use the letter N? What if I have some ex-girlfriend named Nellie who really upset me and I don't want to think about it? So instead I'm going to use the letter X. Okay? So in this case, X is going to represent the unknown number because I just don't like N, and I like the letter X. Xavier, great student. That's why. So if I put X into this machine, same thing happens. Out will pop X plus 3. If you're understanding this, you're doing well because we have just represented an unknown number with the letter. In this case, the letter X. But you guys, I'm sure, are very astute. You know that I could have written anything. I could have written A there if I wanted to, and out would pop A plus 3. Doesn't matter what letter I use. Let's look at another machine. So this cool machine here is a times 2 machine. So whatever I put in, it just multiplies that by 2. So if I put in 7 into this machine, out pops 7 times 2, which is 14. Again, if I put any unknown number in, doesn't matter what that number is, it will double it. It will times it by 2. So out will pop 2 times that number. Again, too lazy to do that. Write number every time, so I'm going to write A. A is a good letter. A for Andrew. So if I put A in this, out will pop 2 times A. The same thing that worked for the numbers here works for letters here. So we're treating A as if it were a number. We just don't know exactly what number it is. Now, as I said, I'm really lazy. So what usually happens with me and with most mathematicians is we don't write the times. So here for X plus 3, we definitely wrote the plus. But if we have a times, like 2 times A, we usually just write that as 2A, 2 lots of A. Again, just pure laziness. It makes life a lot easier. So again, we've just represented letters for numbers. So we will go on now, and hopefully you'll be able to string together some of your own sentences. Okay, so what I want you to be able to do is to write a sentence in a shortened form using mathematical symbols. So we'll start with the first one here. So to understand this process, let's write the sum of 5 and 2 with mathematical symbols. So I'm not giving the answer. All I'm doing is writing that exact same sentence, but in a shorter way. Now, sum, you should all know, means adding, plus. So the sum of 5 and 2, I can simply write as 5 plus 2, okay? If it was the sum of 10 and 2, I could write that as 10 plus 2. Sum of 13 and 2, I write it as 13 plus 2. So it works exactly the same way if instead of using numbers, I use letters. So how would I write the sentence, the sum of an unknown number x and 2, in a shortened form with mathematical symbols? And it's simple. I would just write x plus 2. So I've done exactly the same process as what I did up here. So I've used this unknown number, x, in exactly the same way I would use a known number. So the sum of 5 and 2 is 5 plus 2, so the sum of x and 2 is x plus 2. Let's do one more. So if I wanted to write the product of, say, 2 and 9, you should all remember product means times, I would just write 2 times 9. The product of 3 and 9 would be 3 times 9. The product of 4 and 9 is 4 times 9. So the product of A, an unknown number, and 9 would just be A times 9. But remember I said that usually this is written as just 9A. So if you see something that says 9A, it means 9 multiplied by whatever A is. Alright, if you're okay with this, you're doing really well. A little bit more to go. Let's have a go at this question. So if Jamie has X friends and he makes 3 new friends, how many does he now have? So the point is that when we're doing this sort of algebra, so we're just transferring sentences into mathematical statements with mathematical symbols, you can't give me a definitive answer. You can't tell me Jamie has 30 friends or 23 friends or whatever. You don't need to. See, the thing is that we have been told Jamie has X friends. Remember, X just means an unknown number. So if you don't know how many friends he already has, you can't tell me the number of friends he will have after he makes 3 new friends. Right? So your answer isn't going to be a number. But let's visualize as if it was. So if Jamie had 17 and he made 3 new friends, he'd now have 17 plus 3, which is 20 friends. If he had 397 friends on Facebook maybe, and he made 3 more, he now has 400 friends. He must feel awesome. So, if we had a number of his friends, if we were told that he had 15 friends, we just add 3 to it. So we do the exact same thing when we have a letter. So if he has X friends and then he makes 3 new friends, he now just has X plus 3 friends. That's it. You're done. Answer correct, even though you didn't give me an actual number. And we have to get comfortable with that. So not everything that we're doing in this algebra section of the course will be a number for an answer, like the number 4. It will have letters in it. Alright, one more example that I want to go through. So, let's look at the question here in blue. So, if I had n smileys and I were to divide them amongst 3 people, then how many smileys would each person get? So, I put a little picture there for you because everyone loves smileys, but also to show you that, again, what works with numbers works with letters. So, I have 9 smileys over here, okay? If I wanted to divide them amongst 3 people, it'd be pretty easy. I could just divide, say, these 3 first person gets, these 3 next person gets, and these 3 the next person gets. So what I'm doing is I'm dividing 9 by 3, and I'm giving 3 to each person, okay? So I've taken the total number of smileys, 9, and I've divided by 3, and that's how many each person gets, okay? So that's what I did when I had a number of smileys that I knew. I had 9 smileys, so I do the same when I have n smileys. If I want to divide it amongst 3 people, I take the total number of smileys n, and I divide it by 3. And we usually write it like this. If you wrote n divided by 3 like that, it's fine, but we usually like to write it as a fraction. And when we do terms, you'll come to see that a bit more, okay? So what worked over here with numbers works over here with letters. We treat letters the same way we treat numbers in algebra, okay? So again, the answer I gave wasn't a definitive number. It doesn't need to be because we didn't know how many smileys we had originally. However many we had, we divide it by 3, and that's how many each person would get. Okay, I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.